Quantum dawn, the next revolution after AI. There's a quiet revolution happening in the world of technology. It's not artificial intelligence or another social media app or even the next version of the iPhone. This time, it's something far more fundamental, a complete rewrite of how computers work. It's called quantum computing, and it might redefine the future of science, finance, medicine, and even national security. For decades, our world has run on classical computers, machines that think in ones and zeros. Every website, every video game, every AI model runs on this binary logic. But quantum computers don't play by those rules. They use qubits, or quantum bits, which can exist as both 1 and 0 at the same time. It's like flipping a coin and having it represent both heads and tails simultaneously. That strange behavior, known as superposition, gives quantum computers an entirely new dimension of power. To understand what that means, think of today's computers as explorers walking through a forest, taking one path at a time. Quantum computers, on the other hand, can explore all possible paths at once. That ability could help humanity solve problems that today's most advanced supercomputers would take thousands of years to compute. IBM, Google, and Microsoft are leading the modern quantum race. And while they're competitors, they're united by a single mission: to turn the strange world of quantum physics into a tool that industries can actually use. IBM recently unveiled its Loon processor and Nighthawk chip, designed to handle complex quantum computations more reliably than ever. Their researchers describe it as a step toward a fault-tolerant quantum computer, one that can operate effectively even when some errors occur. And that's crucial, because quantum bits are delicate. A small vibration, a bit of light, even a minor temperature change can destroy the entire calculation. IBM's engineers are now building systems that can correct those errors automatically, like a self-healing brain for machines. Microsoft's approach is different. Its Majorana 1 chip uses an exotic particle to make qubits more stable, potentially creating a new state of matter. If successful, it can make quantum computers cheaper, smaller, and more reliable, bringing them closer to everyday applications. And then there's Google. Their Willow chip has already demonstrated breathtaking capability. According to the company, Willow can perform in 5 minutes what would take a classical supercomputer 10 septillion years to finish. That's a number so large it's practically incomprehensible, and it hints at what this technology could unlock. But this isn't just about faster computing. It's about what faster computing enables. Quantum computers could revolutionize medicine, energy, finance, and security all at once. In healthcare, quantum models can simulate the behavior of molecules too complex for today's machines. This means scientists could design new drugs or treatments in days instead of years. Pharmaceutical companies like Biogen and consulting giants like Accenture are already testing these possibilities, using quantum systems to map molecular interactions and predict outcomes that used to take entire research teams a lifetime. In the automotive and energy sectors, companies such as BMW and Airbus are exploring how quantum simulations can help build lighter materials and more efficient fuel cells. The promise is simple: cleaner energy, faster development, and smarter design, all powered by physics itself. But perhaps the most transformative impact will be in finance and cybersecurity. Quantum computers can process massive amounts of data in parallel, allowing them to simulate markets, model risk, and optimize investments on a level we've never seen before. At the same time, their ability to break traditional encryption systems has set off alarms across governments. The same power that can simulate nature can also crack the digital locks that protect global communications and financial systems. That's why the race to develop quantum-safe cryptography has already begun. According to McKinsey, quantum computing could create $1.3 trillion in new value by 2035. But it's not just about economics. It's about scientific discovery. Quantum computers could allow us to understand the origins of life, create new materials that harvest energy more efficiently, and even simulate the universe at a fundamental level. Still, there's a long road ahead. Experts estimate that fully reliable, fault-tolerant quantum machines are at least a decade away. Today's prototypes still struggle to maintain stability for more than a few microseconds, but progress is accelerating. What once felt like science fiction is slowly becoming engineering fact. And here's where the story gets interesting. quantum computing might become the technology that powers the next generation of artificial intelligence. Training massive AI models, the kind that run language systems, medical imaging, or financial forecasts, requires enormous energy and time. Quantum processors could train those same models millions of times faster. That means better AI, cheaper computation, and perhaps an entirely new category of intelligent systems that blend neural networks with quantum physics. Think of it as AI's second engine, a brain powered not by electricity, but by the strange rules of the universe itself. Every revolution in computing has had a signature moment. The transistor in the 1950s, the personal computer in the 1980s, the smartphone in the 2000s, and artificial intelligence in the 2020s. Now, quantum computing stands at the edge of the 2030s, ready to become the next defining leap. But unlike AI, which burst into public consciousness overnight, quantum will move quietly, first in labs, then in corporate research divisions, and finally into the cloud. Most people won't even know they're using quantum systems when they do. It'll happen behind the scenes, accelerating drug discovery, securing transactions, optimizing supply chains, and transforming industries. Investors, of course, are already watching closely. Publicly traded players like IBM, Microsoft, and Alphabet are leading the charge, but startups like IonQ, Rigetti, and Quantinuum are pushing boundaries in hardware and software. There's also a new wave of companies building tools for quantum-safe encryption and cloud-based quantum access. If this pattern sounds familiar, it's because we've seen it before. The early days of the semiconductor boom when a few small companies quietly built the foundations of modern computing. Quantum may follow the same path, turning today's niche research into tomorrow's trillion-dollar industry. Of course, the challenges are immense. The physics is unforgiving, the cost of development is enormous, and the talent required sits at the intersection of electrical engineering, mathematics, and theoretical physics, a rare combination. But that's exactly why breakthroughs here are so valuable. They represent the hardest problems humanity can tackle, and the biggest opportunities once they're solved. As one expert put it, right now we're trying to do brain surgery using a spoon and a fork. Quantum computing will give us the scalpel. That image captures both the difficulty and the promise of what's coming. When the first practical quantum computer finally arrives, whether in 2030 or 2035, it won't just change how we calculate. It will change how we think. It will allow us to model the complexity of life itself, simulate economies, forecast weather with perfect precision, and perhaps even decode the chemistry of consciousness. In the end, the rise of quantum computing isn't just another chapter in the story of technology. It's the story of humanity's relentless quest to understand the universe, and then use that understanding to build something extraordinary. So while the world keeps debating artificial intelligence, remember this: the real revolution might not be in the algorithms that think like humans. It might be in the machines that think like nature. Quantum computing is coming. And when it does, it won't just change technology. It will change everything we believe is possible.